So on the subject of waking up, and now that it is 7:47, we shall move forward with our guest because, and if somebody wants to go for this one as well, our story tonight really centers on New Horizons.
Wake up with Susie.
Yes. Who said that? Okay, you also get a prize because that is why we put it in here. Because New Horizons woke up, in fact, the Saturday morning after the last Allspace, probably before I woke up the next day, and is now on its way, well, it has been on its way to Pluto for quite some time, and is now getting ready for its final approach. So with that, I would like to just say a few words about our speaker tonight, and then we can bring him into the room virtually. Our guest is Dr. Alan Stern, who is a research astronomer and scientist who has such an amazing history. It's hard to pack it all in, so I'm just going to briefly say, for tonight's purposes, what you want to know about him is that he is the principal investigator. That means the top dog of the New Horizons mission. Alan pioneered the Southwest Research Institute in Boulder, which focuses on planetary studies and is a powerhouse of planetary studies in the United States. He was the associate administrator for the Science Mission Directorate. It means he was the head of science for NASA for a while. He is involved in private space. He is involved in education. He's involved in all sorts of aspects of space exploration. He's a pilot. He was an astronaut candidate who was training but never flew on the shuttle. So he pretty much knows it all, has done it all, and we are very glad to have him with us tonight. So if we can now flip the switch and see if Alan successfully comes to the room. Hey. Hi, Alan. I don't know what you can see, Alan, so we'll try to just, hi there, I think I'm in the corner, I can see me.
Or I'm just watching you.
Yeah, nice to see you. Welcome back. You just got back from Tucson. What were you doing there?
I am the chief scientist for a company called Worldview, which does stratospheric ballooning and is planning to fly a lot of science payloads. So meetings down in Tucson today.
Wow, that's a whole other side I didn't even mention in my introduction. Well, it's great to have you here, and congratulations on so many things, but congratulations on this final approach for New Horizons. I think you must be pretty excited about it.
What do you think? Yeah. So 9 years, 3 billion miles in the rearview mirror, and we are now on Pluto's doorstep.
So how long have you been trying to get to Pluto, and how did that all come about?
I've known you. Actually, a group of us got very interested in exploring beyond where Voyager had explored at the time that the Voyager mission was finishing at Neptune, all the way back in 1989. And it took 14 years to get approval for the mission into the early 2000s. And then we spent a few years building it, and then we launched it in 2006. And we've been flying it for 9 years.
So you hit some obstacles along the way to get to the point where you finally were able to launch. Can you say a little bit about that? What were some of the challenges you had to overcome?
Well, I think the primary challenge was just that it takes a long time to get a mission to the top of the priority queue. And as we would make the case for why this mission and not others should be top dog for funding, sometimes it got a little bit upside down, and for one reason or another, one NASA administrator or another would decide to do something else. And I think what we learned from that, and what I hope people in your audience learn, is just like in business, in science, you have to stick to it. You have to stand up for what you believe in. If you get knocked down, you have to stand up again and again. And that quality of persistence was really the hallmark of the people who wanted to see this new third zone of the solar system beyond the giant planets explored. And they stuck with it for 15 years. And in the end, the National Academy of Sciences ranked the mission as #1 on the runway. And that's what made the difference.
So tell us a little bit about why. What is the rationale that finally got it pushed to the front of the queue? Why do we want to go see Pluto? It's so little. Why do we care?
Yeah, well, first let's talk about how little. If you drove around Pluto's equator and clocked the mileage, it's almost exactly the distance from Manhattan to Moscow. So it's not too small. It's pretty good. But it's not that it's Pluto, it's the science that comes to a nexus there. And before we knew about the Kuiper Belt, there were lots of interesting threads. For example, Pluto has a large moon called Charon that's pretty well pinned down in terms of formation mechanism to have formed the same way as the Earth-Moon system. And it's the only other example in our solar system that we knew of in which we had this same formation mechanism. We get another example to study. Then there was Pluto's atmosphere that is very rapidly escaping, primarily because there's a greenhouse up high that makes it warm. And the process of Pluto's atmospheric escape, which is called, this big word, hydrodynamic escape, is actually how the Earth lost its early hydrogen-helium envelope billions of years ago. So it's kind of funny that you have to go all the way to the other end of the line, the farthest reaches of the solar system, to find these things that can teach us about our home planet. But those were all important threads. But what really did the trick, what made the difference, was the discovery of the Kuiper Belt. Not all the little comets like Comet CG that you just saw, it's just a few miles across. Not even the KBOs, the Kuiper Belt objects that were first popping up in the 90s, that were, let's say, the size of little tiny New England states. But what really did it was the discovery that the Kuiper Belt is littered with small planets, with names like Makemake and Eris and Sedna and so forth. It was the context, it was the realization that the Academy had that there was a third zone to the solar system, but also a third class of planet. And that after 50 years of planetary exploration, we had not been to this class at all. As long as Pluto was a misfit and a loner and an oddball that just got discovered decades ahead of its time, it could be interesting, but not really truly centrally important. But once we got the context that the solar system was so good at making little planets, and that the little ones actually are more common than the giant planets and terrestrial planets combined, then all the light bulbs went on in the committee, and eventually above the committee level, the entire decadal survey, that we need to go do that. That's what made the difference.
So in fact, when declassifying Pluto as a planet and reclassifying it as a dwarf planet in some ways helped you because it put emphasis on the dwarf planet as a population to study?
Well, I see what you're getting at, but we can't really say that. And the reason is, by the time that the International Astronomical Union embarrassed themselves with that, we already launched. We were off the Earth and on our way to our Jupiter flyby at that point. So things happen in a different order.
I see. So you've mentioned a couple times the three zones, and just for the people in our audience who may not know what those three zones, do you want to just recap that a little bit about the terrestrials and Jovians? And
Sure. So if you think back to when you were in grade school or whatever and took that lesson on the planets, there are the four inner rocky planets, which we call the terrestrials after the Earth: Mercury, Venus, Earth, and Mars in that order. And then the next zone are these freakishly large giant planets. Jupiter, 300 times the mass of the Earth, a little bit bigger actually. Saturn, 100 times the mass of the Earth. And then Uranus and Neptune, both 15 or 20 times the mass of the Earth. That's what we used to think of as the outer solar system. But with the discovery of the Kuiper Belt, now we know that's the middle zone of the planetary system. In fact, some people like to say that New Horizons is the first true outer planets mission.
That's great.
The first mission to the third zone.
Yeah, that's wonderful. So tell us what's going to happen this year.
Well, this year we arrive. And the mission is a flyby. We're going very fast in order to cross the 3 billion miles of space. In fact, New Horizons is the fastest spacecraft ever launched. To give you a feel for the speed, I'll give you two metrics. One is, for 9 years, the spacecraft has been flying so fast that it could go LA to New York every 4 minutes. 24/7, all the time. And let me put it another way. When I was a little kid, Apollo missions used to take off to the moon at 25,000 miles an hour, and with their hair on fire, get 250,000 miles away in 3 days. New Horizons did that trip to the moon in 9 hours. It was about 3 days, so about 10 times faster.
Alan, you may remember I was at the launch, and
That's
we
right.
were all still together when New Horizons reached the moon, and that was mind-blowing. Yeah, exactly, at the party. Right.
Yes, absolutely.
With Henry Throop dressed as Pluto with his makeup all
That's
over.
right. With the plastic. So we've been traveling all these years through this great wilderness, this vacuum of space between the planets. And beginning January the 15th, we start this flyby. We're going way too fast to slow down in orbit. We're going way too fast to land. Instead, we designed the payload of instruments to start making discoveries months out. So it's not like a weekend at Pluto after a 9-year journey. We'll be better than Hubble by early May, and for about 20 weeks, we'll be studying the system at close range. It's a long flyby with lots of time to make different kinds of measurements, even to watch Pluto. Maybe the weather evolves, maybe the surface snows are moving around, we'll have to see. And then after that, we're going to fly on. The spacecraft is going so fast it will escape the solar system. But on the way to leaving the solar system, we hope to fly by one or just maybe two small Kuiper belt objects that are the building blocks of dwarf planets like Pluto.
And will you go, we told the story in here, I think 2 months ago, about the Hubble observation of a potential target. Are those, that's what you'll be, can you tell me which one are you going past? Have you selected it? Is it definite?
Not yet. In fact, we have 2 targets that we're tracking, and we've agreed with NASA headquarters that we won't make a selection until next August.
Wow.
After the Pluto flyby. We'll see how our fuel supply is. One of them takes more fuel than the other. Kind of maddeningly, the bigger one, the brighter and bigger one, the more interesting one scientifically takes more fuel, and the little bit smaller one is the cheaper one. But regardless of which we pick, the flyby will be in 2019. One of them is in January, and the other is in March or maybe the beginning of April.
So sticking with this year for the moment, I believe it's July 14th of this year is the closest approach, and I can tell you I remember that seemed so long into the future at one time, and here it is coming fast. And you know, at Griffith Observatory we like to have parties. So should we have a party on the 14th, and if so, what time of day and what should we expect? Are we going to get to see anything, or should we just have an all summer long party?
Oh, you should do both. Why limit yourself? So first of all, anybody can have a party. We're putting together kits that anybody can order if they have an astronomy club, a class, a company party, a neighborhood party, a Griffith Observatory party. They're called Pluto Paloozas. You need to get one. And you can have your party on the 14th of July. That's Bastille Day. And to celebrate, we're going to storm the gates of Pluto. But you could also have your party other days. You can have on July 4th, because you know it's really this country and all of us who are taxpayers that paid for all this great exploration. And I don't know if your audience knows this, but the United States has been first to every planet in the solar system, which is quite an accomplishment. It's really something I think we go down in history for, and more than just going down in history, that people will write about this very special time, I think even centuries from now, the first reconnaissance. But in classrooms around the world, when people read about the planets, when little kids, whether they're in Asia or Africa or wherever, they read these brand names like Voyager and Mariner and Viking and New Horizons someday. And that's just tremendous, a tremendous way of without browbeating, talking about what we do that's great in this country. And so you could have your parties July 1st, July 4th, July 14th, but you asked what will happen. And it's actually a really interesting story. New Horizons is a really groundbreaking mission in several ways, and one of them is that it's a very inexpensive deep space exploration mission. It's only about 20% as expensive as Voyager. And to do that, we had to really keep our eye on the ball, and we really had to make some compromises. And one of them is that the communication system doesn't have an articulated dish antenna that can talk to the Earth while the cameras are pointing separately. So what that means is we have to choose on any given day between talk to the Earth or study Pluto. So on the 14th of July, we have consciously decided, what do you think? Here's the day we're closest. The entire day, we're going to be spending our time getting pictures of Pluto, its satellites, doing mapping, doing composition spectroscopy and other things, and starting up just about midnight the night before, we won't hear from New Horizons anymore. It's heads down at the Pluto system. And as you may know, there's some danger that the spacecraft could actually get shredded by debris in the Pluto system. We think it's less than 1% chance, but there's going to be a little bit of drama that night, late on the night of the 14th, when the spacecraft turns back to the Earth to check in for about 10 minutes and tell us if it made it. So about 10 o'clock Eastern time, about 7 o'clock on the West Coast. I think there'll be a little bit of drama there. It'll be on the web, and everybody can join in, whether you're in a Pluto-Palooza party or somewhere else.
Well, we will all have our fingers crossed, toes crossed, you know, prayers in line, whatever it takes to hope that it is a very successful flyby. Can you spend just a minute getting a little more technical about what some of those observations are and will be? You know, what specifically you mentioned, trying to understand the formation of the Pluto-Charon system. You mentioned the atmosphere. What are some of the big science questions, and how will you answer them? In just a minute. I know, it is. But if you could try to attempt to answer that with just a few minutes.
All right, sure. Well, okay, but before I get technical, I have to show you our mission bumper sticker.
Oh, is this the one I have?
I don't know. It's the best bumper sticker in the space business.
Good one.
How many people can drive a car with that on there? That's very
anyway, it's true. My other vehicle is on its way to Pluto.
That's great. Do you have it on your car?
What am I going to do after July? I'm going to have to get a new bumper sticker.
That's right. And do you have it on your car?
I do have it on my car.
Yeah, so everyone knows when you're driving by. That's wonderful.
I bought that car the year that we launched, and it drives just fine, and the bumper sticker looks good. So actually, New Horizons, we try to put all of our guns, all of our money on the scientific payload on board. The spacecraft doesn't make a lot of breakthroughs. It's not a lot of new high tech in the spacecraft. It's really about the payload. We have 7 scientific instruments on board, and they are together the most sophisticated suite of instruments ever sent on a first reconnaissance of a new planet, by a lot.
Yeah.
So let me give you an example. We have an infrared mapping spectrometer, which tells the composition of things. And we will blanket the surface of Pluto with spectra at locations. The Voyager equivalent of that instrument had 1 pixel. It's 1970s technology. We built our instrument with 2000s technology. Our infrared mapping spectrometer has 64,000 pixels. Our ultraviolet spectrometer has about 32,000, and the Voyager instrument had 2 pixels. And the entire payload is miniaturized to get it onto this little spacecraft the size of a desk, which we had to build it small to make it go fast so we could get that rocket launched almost empty. The entire payload on New Horizons weighs less than just the camera on the Cassini-Saturn orbiter.
Oh, my.
And when we turn all 7 instruments and their microprocessors on, all of them, they draw about half of 60-watt light bulb. They draw 28 watts. It's spectacular technology in the payload. So we have instruments to do atmospheric composition measurements, surface composition measurements, mapping, color mapping, stereo mapping so we can get height reconstruction of all the geology. We have instruments that study the local plasma charged particle environment of the solar wind and much higher energy megavolt electron particles that are coming off Pluto's atmosphere to measure dust impacts from the Kuiper Belt and possibly from ring systems or debris in Pluto's environment. We have radio science that can determine the pressure and temperature structure as a function of altitude in the atmosphere of Pluto and help us search for an atmosphere around its big moon Charon, which is about the size of the state of Texas. And we can do thermal mapping and a whole variety of other things that we're kind of long enough in the list now that I think I've told you enough about the payload. But I want you to wrap your head around something different about this mission. It's really like a mission from the 60s or 70s when we were going first time exploring and didn't know what questions to ask, but it's done with 21st century technology. So unlike, say, Mars Curiosity lander, where the mission was built around 6 or 7 very detailed questions about the ancient Mars environment and how habitable it was, because Mars Curiosity lander is like the 8th or 9th lander on Mars, and maybe the 20th, I'm just guessing, mission to Mars. This is the first mission to a whole new class of planets in a whole new zone of the solar system. So it's like those early missions in which we're going to reconnoiter. So it's like eyes wide open. We came with the biggest battery of baddest scientific instruments we could design. And we're just going to see how dwarf planets look, how they operate, how their atmospheres, their surface, their interior, their satellite systems operate, and how it was formed. And probably after the fact, we'll have a lot of good questions. You know, people always say, this mission's going to rewrite the textbooks. We don't have a textbook to rewrite for Pluto. We're going to write it from scratch.
I know. I remember when I was in school, all the question marks, you know, the table of all the planets, right. And then there are the question marks all the way along on the bottom one. We know a little bit more now, but we still know so very little. I have a slide later in my presentation of Looking Forward in 2015 of our best map of the Pluto surface right now. And
well, it's so bad that if you were looking at the Earth with the same resolution, you wouldn't even see the continents of the Earth. So what could you know? But when we get done, and I have a slide, I could have brought it for you, but we had one of my postdocs, Amanda Zangari, actually simulate what we would see looking down on a familiar place on the Earth if we had flown New Horizons over it with the same instrumentation.
Ah.
So it's a picture of New York City at the same resolution of the best images we would have of Pluto next summer. And you can look down on New York City in this image, and you see the Hudson River and the East River. You can see the different boroughs. You can see Central Park. You can count the ponds in Central Park. You can count the wharfs up and down the Hudson. It's just going to be spectacular. We're going from a picture where you couldn't spot the continents to counting the equivalent of the ponds in Central Park. So we're going to completely transform our knowledge. It's what Carl Sagan used to say about going from a pinpoint to a planet, a whole world, in just a matter of a few weeks this summer. And we're going to use social media and other techniques to bring everybody along who wants to come.
Well, I think everybody's minds are sufficiently blown.